Alright, so here we are solving systems of equalities by graphing. So I want to solve systems of inequalities by graphing, and I want to be able to determine the coordinates of the vertices of a region that would be, say, determined or created by a system of inequalities. So, quick review, you should be able to remember that, what's a broken line, what's a solid line, how do you shade above and shade below. This is graphing inequalities. This is something from, say, Algebra 1. So, but you might want to make sure you have that in there. For some reason you don't have that memorized. Okay, so let's look at this, and we're going to say graph y is greater than 2x minus 4 and y is less than or equal to negative 1/2 x plus 3. So again, we started with our y-intercept. We don't worry about the shading until after I've done the lines. So I'm going to start off with the y-intercept, negative 4, and then I'm going to go up 2 over 1. And it's a broken line because there's no line underneath. Then I'm going to start at 3 for the other one, and I'm going to go down 1 over 2. And I could even go the other direction, up 1 over to the left 2, and make that one. Notice that one's a solid line because there is a line underneath. Now, let's look at the shading. The first one, the green one, is shade above. So I'm going to shade above. I'm going to use a highlighter, and I'm going to shade above. And then the other one is shade below. So I'm going to shade below and do that. And you can see in this little area, or like say off to the left, there is where they cross shade. That's the solution area. So basically that right there is a solution area, and I'm picking out 4 points in each of the 4 areas that have, like, one where they cross shade, 2 where they don't even cross but there is some shading, and a fourth point where there is no shades. So just to show you why we would check that, okay, every point in this little area here is considered a solution. Any other points in there is not. Technically, even points that would be on a solid line would be there, but not one on a broken line. So if I go over to here, and let's say I take these 5 points, these 4 points, which were the 4 points that you can see chosen here, and go here and say start testing them. So like put 0 in there in place of the y and the x. 0 is greater than negative 4, so that checks. And then I put it into the other equation, and I can see that 0 is going to be less than or equal to 3. So 0, 0, which is this point here, which is in the cross-shaded area, works. So that should tell you that every point will work in the cross-shaded area, where that the y will be greater than whatever 2 times x minus 4 would be, but the y would also be less than or equal to whatever negative 1/2 times x plus 3 is. Now watch what happens when I do the 2 and 5. I put the 5 in place of the y and the 2 in place of the x, and I get 5 greater than 0 for the first equation, so that checks. But I try it for the second equation, and I get 5 is less than or equal to 2, which is not true. So that second point doesn't work. Do the third point, and you're going to get the same results. Now, I'm not asking that you say check every single one or find 4 points in 4 different areas and check them all. I'm just telling you that I'm just showing you the reasons why we say the solutions are equal, because those points that are in that cross-shaded area, every single one of them will keep this little bit of, like, say, will make the left side true in comparison to the right side, because that's really what inequalities are. They're saying that the left side, y, like in the first equation, is greater than whatever 2 times x minus 4 will be. And so every point in that cross-shaded area would do that for both equations, both inequalities, I'm sorry. So you can kind of see that there. Now, let's look at another example here. Here's one that with parallel lines. And just because they're parallel lines does not mean they won't be no solutions. Because what we're concerned with in inequalities is where do the shades cross. So you can see here how I'm graphing, starting at negative 4 and going up 3 over 1, and then starting at positive 3 and going up 3 over 1, and making my 2 lines. The first one shades below, and the second one shades below. So you can see here the cross-shaded area is that little area that I've, say, highlighted in orange and made it look all messy. Any point in that cross-shaded area would be an answer. Any This little sliver in between that's got nothing but just green highlight, that's not cross shaded, so that's not considered an answer. Only the cross shaded area. And don't be surprised if I ask you to say graph to see and ask you, is a point a solution? So does a point fit into that cross shaded area? And I'll even show you how to do this on the inspires later. Excuse me. So what I can see here, this one, I'm going to start at positive 5 and go up 1 over 1. I was going to be at negative 4, go up 1 over 1, but that one's a cross or broken line, notice. And notice the top one, the x plus 5, is going to shade above, where the bottom one is going to shade below. So their shades go in opposite directions. They never cross. So since they never cross, my answer is no solution. Because for this to be true, the shades have to cross each other. If they never cross, then your answer is no solution. So there's an example of no solution. Alright, so now let's look at a region. Why not? Okay, so here's 3 lines. Now I've got 3 lines in here. And I'm going to graph all 3. So the first one I'm going to start at negative 8, and I'm going to go up 2 over 1. So you can see me going up 2 over 1, and it's a solid line, so I make a solid line. The next one says start at 6, go down 1 to the right 4. And the last one started at negative 8 and went, since I couldn't go down 15 and to the right 4, I did the opposite. So I switched it and said it's actually 15 over negative 4. So I went up 15 and then to the left 4 so I can find another point. Now, if you have graph paper, this makes it a little bit easier. If you don't, your drawings may be a little bit harder to see. But with the graph paper, and first off, let's look at the shading. Okay, so I can usually these shade in between. So like you can see, like there's a little triangle being formed here. That's where the shading is going to go. Well, the green one is shade above. The blue one is shade below. The gray one is shade above. So above, below. Notice how those shades are trying to come in between each other. So there you go. So that is my solution area. Just that. I'm not going to even worry about where they cross shade because that's just where they would cross shade. So any point inside that would be considered a solution. But for other purposes, it's very important to know what are the vertices. In other words, what are these points at where they intersect? Because those points become also important for other purposes. So we can see like the bottom one is 0, negative 8. That one's pretty easy. And if you have graph paper, it's easier to see these. And this one over here, negative 4, 7, also can be seen. But this last point is kind of like a decimal point, and so it's really hard to see. So what I did was I would type the green one and the blue one as equations on a graph, just like the way you did systems of equations, and then do the whole menu 6, 4 thing. So not as an inequality, but as a graph, and it will give you that intersection point. So if you can't find an intersection point, then you would have to go to the calculator and do the whole menu 6, 4 to get the intersections. But you would treat 2 equations at a time and then tell it where they are at. Okay, this time around I am going to add word problems, so be prepared for that. This is from an example on page 147, so you can always look it up on your textbook. But you can see here that somebody's trying to study, and we come up with like all sorts of different equations. I'm going to stop this because it's going too fast. So she says she's got to study for calculus at least 7 hours, but no more than 14. So you can see here she's got calculus 7 to 14, and notice how I have a line in between, lines at both of those. And those are solid lines or just horizontal lines. Physics, which is down here, has got to be between 8 and 12. And so she's got that there. And then added together, she can only study 23 hours. So C plus P has got to be less than or equal to 23, which if I want to graph that line, I would have to do something like that and treat that as y and x, and then basically kind of see that there. This is one of those, I think the more you practice with it, the easier it'll get, but we will try to do some of those to practice. Anyways, that's it for today. There you go. Hope you enjoy this. Hope you get a lot out of it. Thank you very much. Helps if I'm pushing the right button.